Now that we've learned how to create measures of association for nominal and ordinal variables in R, let's look to see how to make measures of association for interval ratio variables. So in this video, I'll look at covariance and correlation using R. So recall that in an earlier video, we created a data frame from a SPSS dataset from the General Social Survey 2012. Let's look at the namespace of that resulting dataset, which I call dataset. So if we run that, and we look at the resulting output, we can see that we have several variables to work with. So they include variables like education, father's education, and age. These are the ones that I'm going to use in this video. So going back to my script, the first thing I'm going to do is just attach the data set like I've been doing. This basically just makes it easier to do some of the programming because I don't have to worry about putting the reference to the data frame within which these variables are made. So I'm going to attach this data set, and then later I'm going to detach it. Okay, so the first thing we're going to do is we're going to look at a scatter diagram of father's education by response education. So here the father's education is going to be the independent variable, which will be the first argument that we put in the plot command that we're going to use to make the scatter plot. And the dependent variable is going to be education, the response education. And so I'm going to include several different options with this plot. So the first thing I'm going to include is some kind of a descriptive title. And this is just basically figure 1 scatter plot of education by father's education. And then I'm going to label my axes. So the x-axis, the independent variable labels, I'll label as highest year of school completed father. And then for my dependent variable, the y-axis is going to be labeled highest year of school completed. And that's by the respondent, of course. And then I'm going to have the title command run after this, which will just put a note at the bottom of the table telling us how many cases we're going to use in the analysis. In this case, 1,439. And I'm going to use some end-of-line characters to put on a new line the source of the data, that is the General Social Survey 2012, which I'm going to left align. So if we run this, and then we scroll out into the sort of bigger picture, we can see that R has created the figure in this space. And so we can see that basically here are the values of father's education, here are the values of response education. These dots mark the spot for each record on the respective value for both variables. So here is somebody who has basically like 5 years of education for their father, and they themselves have 0 years of education, right? So we can see that there's kind of a secular trend here, an upward trend. It looks like people who have more educated fathers are themselves more educated, and we can imagine kind of fitting a linear relationship here because it does look like this is sort of a line, although the fit will probably only be about moderate. Okay, so now that we've created a scatter diagram, let's look at some other measures of correlation. So it's all fine and good to have a diagram like the one we just looked at, but we need some kind of more formal measures of the association. So the first thing we're going to look at is the covariance. And so the covariance basically just tells us the pairwise association, and really it's more useful for looking at the direction of the relationship. The magnitude just depends on the underlying units of the variables. And so to get the covariance, I'm going to use the cov command. I have to specify the two variables I'm going to use in the analysis. Here's the independent variable, here's the dependent variable, and then I have to tell it what to do about missing data. And so the use option here basically tells me, allows me to indicate how I'm going to treat missing data. And so I'm going to use the pairwise complete obs. That basically means that I'm going to use pairwise deletion. That means for each pair of variables in my analysis, I'm going to take the complete set of cases that have non-missing data across the two of them. And with only two variables, that's essentially the same as using listwise deletion, or that is deleting any case that has missing data on either of the two variables. So if we run that code and we go to our output window, we see that we have a positive covariance, which is consistent with our scatter diagram. Basically, that means that as father's education increases, so does respondent's education. And so going back to my code, one thing we don't know thus far is how strong is that relationship? Because, again, the covariance depends on the underlying units of the variable, and it's very hard to get a sense of how strong they are independent of those units. And so we can calculate another statistic, the Pearsons Correlation coefficient, or the coefficient of correlation, however you want to refer to it. And this will give us some number that ranges between -1 and 1. And here again, we have to supply a bunch of arguments. The first here is the independent variable, then the dependent variable, and then the way we deal with missing data. here we're effectively using all the values of both variables that are non-missing across the two of them. That is pairwise deletion. And so I can run that, and then if I go to my output window, I see I get a Pearsons correlation coefficient of 0.46. And so that's kind of a moderate association, somewhere in the middle between 0 and 1, and it's positive, meaning that as father's education increased, so does response education, which is consistent with the covariance and consistent with the scatter diagram that we've looked at so far. Okay, so I'm going to basically now detach my data set, so I can run that. And then that means that if I now run any commands, I have to basically tell it which data frame the variables are coming from. Although I'm going to kind of sidestep that a little bit. So I'm going to show you now basically how to make a correlation coefficient for more than 2 variables. Let's say I wanted to do it on these 3 variables: father's education, education, and age. So basically what's going to happen is R is going to create a correlation matrix. And so the way I'm going to do this is I'm going to use a vector that includes my 3 variables, and I'm going to save that as an object, myVars, which is just an arbitrary name. Notice that these variables show up in the way that they do in the namespace. They're all uppercase. And now I'm going to run the core command on my data set. Notice again I have to specify the data set, but I'm going to use these square brackets to indicate that I only want the values of the variables that are found in this object, which is just these 3 variables. And then again, I have to tell it how I want to deal with missing data, and that's with the use option. And so here basically, again, I'm going to use pairwise deletion. So that means I'm going to be using any sets of cases that are common and non-missing to each pair of variables in my analysis. So if we run this, and we look at our output, it's going to show us basically a correlation matrix. So here's how we read this. On the main diagonal, you'll see that we have the value of 1, because that's the correlation of a variable with itself, right? And then on the off diagonal is a correlation of some given variable with another variable. So this would be, for example, the correlation of father's education and education. This is the correlation between father's education and age. So you can see that we already saw that this was a positive correlation. And it's kind of a moderate association. The association between education and age is negative. So as father's education increases, age decreases, and it's sort of a weaker relationship. Notice that this element is the same as this element. This element is the same as this element. This element is the same as this element, because there are actually some redundant elements here. So technically, we could just look at this sort of lower triangle here and interpret the results. But R just prints the entire matrix so we can see everything, although we don't actually have to look at these results because they don't tell us anything new. Okay, so that's basically how we do measures of association for interval ratio variables in R.